Welcome back, ladies and gentlemen. In this video, we are continuing our discussion on points of concurrency. If you remember correctly, in the previous video, we learned about the first point of concurrency called the circumcenter. We are now going to talk about what is the incenter of a triangle. And so far, let's recap. The circumcenter was created by the perpendicular bisectors. Now the incenter that we're going to be discussing in this video, which is created by the three angle bisectors of a triangle. So as we can see right here, BP, CP, and AP are all of our three angle bisectors of that triangle. And what ends up happening with our incenter theorem, or the characteristic of our incenter, is that it is equidistant from the sides of the triangle, equidistant from the sides. So from P to the line AB is equidistant from P to the line BC and from P to the line AC. So making ultimately that PD, PE, and PF are all congruent to one another. And the purpose of actually creating an incenter and finding out where it is to actually find out where the inscribed circle will be on a given triangle. So let's take the compass out real quick and just kind of show us what we mean and construct a inscribed circle. So what ends up happening is, since that each of these blue lines, PE and so on and so forth, are congruent to each other, that means they are equidistant to the sides. If I take the distance from that center, that incenter, to one of the sides, I can actually inscribe a circle perfectly in that triangle. And so that's what really the purpose is of the incenter, is to find out where it is. So let's see how we can use this incenter and its characteristics in some application. So first and foremost, in this diagram, we see that we are dealing with some algebraic expressions. We see that ND is 5x minus 1 and NE is 2x plus 1, and it wants us to find out what NF is right here. And so let's think about this. So we know that these three for sure are congruent to each other, all right? They are equidistant. How do I know it's the distance? Because remember, the shortest distance from a point to a line is the perpendicular, all right, line to that. And so what I can see right here is that these ND and NE are congruent, and I can use that to say that, hey, 2x plus 11 is equal to 5x minus 1. They are equidistant to each other. Let's go ahead and solve. I see that 12 equals 3x when I add and subtract across the equal sign. And then I divide by 3 and I get x equals 4. It wants to know what NF is. But you might be saying there's no expression for NF. Well, the question I have is, does it really matter? It doesn't matter, because NE, ND, and NF are all the exact same length. So take your pick. So we have ND equaling NF, which equals 5 times 4 minus 1, or 19. The value of NF is 19. So let's talk here for part B, though. This is where it gets interesting. It says, can NG be equal to 18? And I want you to take a pause on the video and try to answer it on yourself. Can NG physically be the value of 18? Pause the video and see what you come up with. All right, well, what do you think? Well, we already classified that NF is 19. So can NG be 18? Hopefully you realize that it can not be 18. Well, why is that? Because the shortest distance from a point to a line is the perpendicular line to that segment. So this is interesting, because this perpendicular line, NF, has already been decided that it has a value of 19. So there is no physical way that any other line, like NG, could be less than 19, because it's not the distance from N to AC. And so no, it can't be 18 then. It would have to be something longer. And I don't know exactly what it is. We could probably do some kind of Pythagorean theorem to find it, but we do realize that it could not be less than 19.